Hi, welcome to this lecture. The lecture is titled One to Many Relationship. Here, the objective for this lecture is to understand relationship. So, relationship is a new concept that you will look into, and the relationship is something which comes into picture when we talk about more than one entity. So, here we will be looking at two entities, and we'll try to understand what is a relationship between entities. So if you could recollect, in last couple of lectures, we did look at the SQL queries. We spent good time looking at the select queries with all the possible clause, and we wrote some very interesting uh, SQL queries. But those queries involve just one entity. So we have dealt with one entity. Let's move forward and try to understand what will happen when we'll have more than one entity. So here in this chapter, we will look at two entities, and we'll try to understand uh, the kind of relationships that may exist between entities. And in this chapter specifically, we are looking at one-to-many relationship. There are different kind of relationships that can exist between entities, but in this lecture we will pay attention to one specific relationship, which is one-to-many relationship. Okay, so before I give you the definition of relationship, let's try to understand one concept behind the design. So we will look at the design part of the database as well, because design gets very important when your system becomes a little complex. So we did not discuss the design part when only single entity was involved. That means in our last two or three lectures, we did not pay much attention to the design part because things were very simple over there. But when you have more than one entity, and then you need to think about the connections between the entities involved. And there it helps if we have some design, because using the design we'll be able to model the kind of interaction that these different entities are having in the database. Okay, so here we will look at different design diagrams which are popular in databases. So the first one that you're looking here is called ER diagram. E stands for entity, R stands for relationship. So entity is something I believe I already gave you some idea about. Okay, so entity is something in our real world about which we are creating a database, and an entity has an independent existence, right? So my definition was something like that. An entity is something that has an independent existence, and it has some properties, and we define an entity using the properties. And then we will have relationships, and relationships is something I will define very soon. So the ER diagram that we have here, E stands for entity and R stands for relationships that may exist between the entities. So this ER diagram is a very popular design tool in database community, and this ER diagram doesn't mean that your implementation should be relational. So that's the point that we have right here. So let me use pen. Okay, so here this ER diagram that you're looking at is a very high level abstract modeling in database, and here we do not make any assumption that the database that you are designing is to be implemented in relational uh, mm, database. Okay, so this is kind of independent of your implementation. Doesn't matter whether you implement it using a relational database or hierarchical. This design is independent of your ultimate implementation. But for some reason recently people have moved away from ER diagrams in industry. Now they are preferring UML and other design um, approaches, but still academically ER diagrams are still popular. So if you read some standard textbook on databases, you will find the discussion of ER diagram. So I'll say ER diagrams are still important, but from industrial point of view, somehow these diagrams are losing attraction. Fine. So how about the other kind of data model, which is RDM? So you will be creating RDM for your project. Okay, so you should try to understand what is an RDM. So in RDM, this R stands for relational, D stands for data, M stands for model. So relational data model is again a kind of a diagram which we use to create the design of the database that we ultimately have to implement. How is this relational data model different from ER diagram? Here here these things are written for these relational data models are created with that assumption that ultimately we have to implement our database in relational model, right? So in RDM we make when you create RDM, then it is assumed that this design that you're making will be ultimately implemented in relational model. Okay, so I'll say that relational data model is specific to relational implementation, whereas ER diagram may be used to create a design which may not use relational model for its implementation. So in other words, ER model is more generic, whereas relational data model is more specific to relational databases. Okay, so here I will show you some RDM in this lecture, and there you will see that in the design also you will see some tables. Alright, so in place of entities we will have tables, and you'll see the relationship between tables rather than having relationships between entities. Okay, so here the entity that you have, when you are thinking about entities, then you don't think about table, you just think of some entity from the domain. You don't think about tables. So if you have to design an ER diagram for a university system, then you will identify entities as student entity, professor entity, course entity, and you will not worry about the implementation of these entities when you create ER diagrams. But when you do the relational data model, then you won't have entity. In place of entities, you will have tables. So you'll have a table for student, you'll have a table for professor, and table for departments, courses, so on and so forth. Now, in these models that we will be looking at, which would be used for designing the database, we have different kind of notations. So and we need to stick to one notation. Okay, so in this lecture I'll show you how to create an RDM using MS Access. Very soon we will also look at the MySQL way of creating RDM. So these two would be slightly different from each other. And if you want to or rather create ER diagrams, then in ER diagrams also we have different notations, we have different ways of creating ER diagrams. So the message is that there is a decent amount of variation in the notations that people use to create the database design diagrams. All right, good. And it all depends on the tool that you're using. And when you're using a specific tool, then it is always a good practice to describe what notations you're using. If you're using a notation, then what do you mean by that? Okay, so I will use this slide to have some discussion. So the discussion is about this concept called relationship. So what is relationship? Relationship. When we have relationship, let me also write another term which is often confused with relationship, that is called relation. Often I ask this question, like, what is the difference between relationship and relation in databases? Okay, so we have already looked at relation, right? So I would ask you, what is a relation in a database? So relation, you should say, relation refers to a table in relational database management system. So relation is the technical term for a table in RDBMS. RDBMS means Relational Database Management System. And the example of RDBMS we know, like Oracle, MS Access, okay, MySQL. And what is a relationship then? Well, relationship is uh, an association between entities. Okay, so an association between entities would be called a relationship. These entities you may implement using table, right? So if you say relationship is an association between the entities, that is fine. And if you want to say that an association is a relationship is an association between tables, that is fine too. All right, so the important thing is that you should remember the difference between a relationship and a relation. Relation means a table in relational database management system. Now, interesting thing is that a relationship I just defined, an association between entities, and you already know what is an entity. Okay. Now, the entity as well as the relationship, entity as well as the relationship in relational database management. Oh, sorry about this. I will fix that right now. RDBMS, entity as well as relationship. I think there is some typo here. Okay, relationship. Okay, entity as well as relationship in RDBMS is implemented or represented, whatever you want to use, represented, or you can write implemented. This is giving me a tough time today. Implemented using a relation. What is this relation here? It's a table. Okay, so you might find it a little technical, but it explains everything. If you have confusion about relation and relationship, then this should help. Entity as well as the relationship in RDBMS are represented. I think I should have an R. Are represented or implemented using a relation. Relation means a table. So I should give you an example of a relationship. So how about this, right? We understand the university database system pretty well. So let's think of some relationships, and here I am using an ER diagram. So in ER diagram, we use rectangles to designate entities. Okay, so here let's think about the entity student, and we can take another entity, courses. course. Okay, students or courses. If you want to make it students, that's fine too. Courses. So there is a relationship between the students and courses, right? So like you are my student, and you are registered in course. So you are either registered in ISC 305 or ISC 503. But you are students, right? So you have your name, you have your ID. So there exists a relationship. And in ER diagram, we have different notations to show the relationships. And I will tell you what those are. Rectangles means entities and diamond means relationship. So student and course, they have a relationship. That's the reason we are connecting these two with the help of a diamond. Now you should give some name to this, right? So how about this? You are registered in. Okay, so I'm defining a relationship which I'm calling as registered in, and this relationship exists between the two entities like students and courses. All right, so what will happen excuse me, we can have the instance of student entity. So let's I hope you remember what is an instance. Instance means if you have the record of the students, if you have a table with the students, then one record, one student that is present in the students database would be an instance of student. As an example, say John Smith. All right, so John Smith is an instance of the student, and that guy is registered in ISE 305, assuming that there is somebody with name John Smith who is registered in my ISE 305. Okay, so this instance of the entity which is student, so this is student, this is the instance of student entity John Smith, is registered in ISC 305. So there is this association between John Smith and ISC 305. We have an association, which means we have a relationship between John Smith and ISC 305. And the relationship is that John Smith is registered in ISC 305. So the important thing is that when you create a database, that you not only store the information about entities, you also store the information about the relationships that exist between entities. Okay, so that was my attempt here in this slide to give you some idea about relationships. And the diagram that you're looking at is ER diagram. All right, and there's another thing actually, the cardinality. I will come to the cardinality later when I discuss that on my lecture slides. All right, so now what do we have here? Okay, interesting. So these relationships that you have between the entities, they have some type. Okay, so let me go back to this one and tell you the type of the relationship. So here the type of the relationship is dependent on the entity instances, right? So let's think about this scenario. Students can be many students, right? So in my ISC 305 and 503 class, if I'm teaching together, I have some 17 students right now. When I teach ISC 305 in regular semesters, I'll have some 125 students. So what will happen in this case is that some 125 students, or say even 17 students, they are registered in one course which is ISC 305. So the relationship that we are talking about, um, sorry, the type, right? So here we are looking at the type of relationships. So in relationships, we define relationships by a notion which is called cardinality. Okay, so you can call that cardinality, and you can also use another name which we have right here, multiplicity, right? So let's look at multiplicity. So right here I am trying to give you some idea about Multiplicity. What is multiplicity? So multiplicity means that when you define a relationship between these two entities like students and courses, then how many instances of student entities are associated with one instance of course entity. Okay, so as I've given you the example, right, currently if you're looking at summer of 2020, then I have 17 students. So these 17 students are registered in one course, okay, which is ISC 305. Alright, and in my regular semesters there might be even more. You can have 125 students registered in one course, which is ISC 305. Okay, so many to one. Okay, so many students are registered to one course instance, which is ISC 305. Right, but it is possible that a specific student who is John Smith might also be registered in multiple courses, right? So 17 students are registered in ISC 305, but it is also possible that a student like John Smith is registered in 3 courses in summer of 2020. Alright, so in this example that you have of the relationship between students and courses, we have the possibility that the multiple instances of students are registered for multiple instances of courses, right? So here the multiplicity is m to n. M to n, why m to n? Because if you take a specific course like ISC 305, you'll find multiple students registered for ISC 305. And if you take one student like John Smith from a student instance, then this John Smith may also have registered in multiple courses. Alright, so for that reason it is many to many. Alright, so multiplicity right here is many to many. So the relationships are defined by the multiplicity, which boils down to the number of entity instances involved in the association or the relationships, and here we will have many to many. In this lecture, we will be looking at one to many kind of relationships. Okay, so let's try to understand what could be one to many relationships. So we have this example which I'll be using in this lecture, but let me give you another example somewhere right here on the top, because I don't want to mess up with the remaining contents. So example of one to many. So let's think about this. If you have an entity called country, okay, and then you have states. Alright, and then you define a relationship, okay, has A, and you can come up with a better term which will show the relationship between country and states. So if you have the state's name as Texas, then the corresponding country should be USA. And if you have a state like California, corresponding country should be USA. Similarly, New York, it should be USA, right? And for other countries, you'll have the corresponding states and map to the country. Now you should see that one country instance like USA will have some 50 states, right? So this is one too many. One country will have multiple states, but one state will only belong to one country. Okay, so it's not like the previous case where we had course and student. One course has multiple students, and one student can also be registered in multiple cases. So here it was many to many, m to n. M is for many, n is for many. Whereas right here, the example that you're looking at is one to many. Why? Because one country will have many states, but the state, example of a state instance, if you take like New York, then New York only belongs to one country, that is USA. Alright, so I hope that this is giving you some idea about the relationship types. You can have many to many, one to many, one to one. Okay, good. So the example that we'll be using in this discussion or this lecture revolves around the shares again one more time. So what I have done, I uploaded these two files for you to download on the blackboard, and so as I'm doing the exercise, you should also do the same, and we will try to understand what kind of relationships do we have between these two tables. So if we create a table called nations by using the nation file, and another table called shares using the shares file. Right now I have uploaded shares 2 because this shares file is different from the shares file that you already worked on, right? So what is the scenario? Let's try to understand the scenario behind these two files. So this is about the stocks who are listed in different countries. Okay, so we have two entities. One entity is nation, okay, and the second entity is shares. So what happens actually, if you look at the shares that we have in USA, then these shares are listed in USA only. Similarly, you can have the shares in Australia, they'll be listed in Australia share stock. And similarly in the stocks or the shares which are there in UK, they'll be listed in UK, right? So we have the country information in the nation table and the shares information in shares 2 file, which we'll use to create shares table. Okay, so that's about it. And interestingly, the kind of relationship that we have between these two entities, which is nations and shares, is one to many. Because in one country you will have multiple shares, whereas one share would be only listed in one country. You won't have the same share listed in different countries. So that's the assumption we are making in this discussion when we take the example of nations and shares. So to my slide example, shares of the stocks are listed in exchange in a country. One country may have many stocks listed, and a given stock is listed in only one country. Alright, so now here let's look at the two tables. It's an RDM because in relational data, um, in the RDM we have the tables represented and the connections between those. So here you see a kind of a nations table, and then you have the shares table, and there is a connection. This connection is defining the relationship between these two. And the notation that we are using here is the workbench notation. So workbench is a tool which we have for MySQL. This is MySQL workbench. We will install that and we will learn to create these RDMs, but for the time being let's not worry about creating those. Let's try to understand what this notation is saying. So in this notation, this part that you have right here, okay, means one. That means one nation. Okay, in this relationship that we have between nations and share, one instance of nation is associated with multiple, right? So when you see a notation like this, it means one, and when you see a notation like this, okay, which we have right here, it stands for many. This is one, and this notation that you're looking at is called Crowfoot. Crowfoot notation. So I do have a slide in which we have the details of these notations, but these notations are representing a relationship between nations and shares, and the fact that you have two vertical lines next to nation and a crowfoot. This is called a crowfoot, which has, this is crowfoot. The crowfoot side you have close to shares. It means that one nation instance will have multiple instances of shares, whereas one instance of share will only correspond to one nation. One share cannot be listed in multiple nations. So that is how we show the relationship between the tables using the workbench model. Okay, good. Let's move on. Now, as I mentioned that the multiplicity which we are trying to learn between the two entities, it specifies like the relationship between the entity instances, identifies the multiplicity between two entities. Okay, so we can have one to one multiplicity, you can have one to many, or you can have many to many. So I've given you the example of many to many, which was between the student and courses. That is many to many, because one student instance may map to multiple course instance, and that will represent a student in a semester registering for different courses. And if you look at course, then for course also you can have multiple students registered. So that is many to many. And one to many we just saw with two examples. I gave you the example of what was that, the country and the states. And then similarly, this example that we have, which is between the country and the nations and the shares, that is one to many. You may find a lot of one to many. One to one is little interesting, and let me see what can we have for one to one. How about this? One to one would be an interesting scenario. How about this? Country and the capital. Okay, so as far as I could recollect, or I'll make an assumption that the capital is unique. You don't have one city that will serve as the capital for more than one country, right? So that is an example which I will consider as one to one. Okay, one country instance will have a fixed capital, and similarly one capital, which is a city, would be assigned to just one country. You can think of similar examples. We can have example like department and department chair, assuming that a department chair may not serve for multiple departments. Okay, good. Alright, so multiplicity, I believe you got it. It's a constraint, or it's a property of a relationship which exists between two entities, and it will identify the association between the number of instances of one entity with the number of instances of the other entities that are involved in the relationships. Alright, so in the RDM, how do we show that? So in the RDM, the way we use in the MySQL workbench, we use the crow feet notation, right? So this notation that you're looking at is called crow foot or crow feet. Why? Because this symbol resembles the crow feet. Okay, so many side, this we have borrowed from here, right? So this is one to many, and in this lecture we are paying attention to one to many relationship. So the same symbol that you have right here in this figure has been taken, and we are trying to explain that right here. So the one side has a simple character, connector, which are two vertical lines, whereas the many side has the crow feet. And there the vertical line that you see, like this one, okay, this stands for the minimum number. So that means minimum of one we need, and here also minimum of one and maximum of many. Okay, so these notations are interesting, and I have the next slide that explains it. So when you're looking at the multiplicity which is being shown using a crow feet model, then if you have one as the vertical line on the line connecting two entities or the tables, then it means that one instance of the corresponding entities. So if you have an entity right here, okay, let me call this E1. That means one instance of E1 is involved with the relationship in that relationship instance with the entity right here. So we can write E2 here. Right, so this side we are saying that in the relationship that you have, we don't have any notation right here. That's not important. Only consider like how many instances of E1 are involved in that relationship. So the fact that you have one vertical line on this line that is connecting E2 and E1 will assume that one entity instance of E1 would be involved in the relationship, right? And now in place of one vertical line, if you have the crow foot like this, then it means you have multiple, or you have many instances of E1 which may be involved in the relationship with E2. Let's write E1 one more time. Okay, and if you put two vertical lines, then that is imposing even more strict rule that says one and only one. Okay, it cannot be more than one, it cannot be less than one. So very strict requirement that one entity instance from E1 is to be involved in the relationship with E2 if you have on the left hand side. Okay, so how about, see here you had two one, that means minimum of one, maximum of one and only one. Here in this case, when you put 0 and 1 here, then it means that either 0 or 1, maximum 1. Alright, so this thing right here that you have, a 0 corresponds to 0. So when you have 0 and 1 vertical line, then it means that if you have E1 right here, we are saying that we can have at most one instance of E1 involved in the relationship, right? Maximum is 1, minimum is 0. And how about this one? So here we are specifying the minimum. Minimum is 1 and maximum is many. Here we did not say minimum as anything, right? So here we did not say minimum as anything. We are saying it is many. But here we are more explicit. We are saying, the minimum is 1 and the maximum is many. Okay. And how about this one? Here we are saying minimum of 0 and maximum is many. Alright, so these are some interesting notations which we may use in crowfoot notation when we are showing the multiplicity between the entities, and this multiplicity will characterize the relationship that exists between the two entities. Excuse me. Alright, so what is ER modeling? Let's have a look at that. So entity relationship modeling provides a visual representation of data. I will also say that it represents the visual representation of the database system that we have to design. And it's a top-down approach, because how do we do it? First we look at the problem statement which we have for designing a database. From that statement we would identify different entities. So first we'll identify different entities, excuse me, yeah. And after identifying different entities, then we will look at the possible relationships between entities. Okay, so first identifying entities, then the relationship between entities, and then further we will look into the different attributes that will characterize each entity, and then we'll look at the multiplicity of the relationships, so on and so forth. So this is a top-down approach to database design. Okay, why top down? Again we have it right here. Identify entities first, and then identify relationships between entities, and then when you have to implement it in relational database, then you can implement each entity using a separate table. Okay, and how do we implement relationships? It depends on the kind of relationships. Sometimes we need to create an independent table for a relationship, and sometimes we don't need to create a new table for relationship. We can just implement relationship with the help of some columns. I'll discuss about that. Okay, so after identifying entities and relationship between entities, then we will add more details to the diagram. We'll add more attributes for entities, we'll add attributes for relationships, and then we will think about different constraints that might exist. So constraints are interesting thing. right? So when you have the attributes of the entities, you might identify some attributes as the primary key, right? So primary key is a constraint, and you may also identify foreign keys. If your ER modeling supports that, then you can have foreign keys, but I think ER doesn't support foreign key notations. You can think of the constraints on the relationship, so which is multiplicity, right? So you will identify multiplicity, and you will identify different attributes for entity as well as for relationships, right? So this is a top-down approach, right? It's a top-down approach. First you start with entities, then you look at relationships, then once you have identified entities and relationships, then you keep on adding more details, right? So these more details would be in the form of constraints on entities or on relationships, and also on attributes, right? So for attributes, you can have the constraint in the form of the domain constraint, which will put a constraint on the values that an attribute can take. I think I gave you this example about grade, right? So if grade is an attribute in transcript table, then it depends on the system, right? Like what kind of grades the system is allowing. So if you're creating a university database, then the grades that you have in one university might be very different from the grades that you have in a different university. Like in Stony Brook University, we have the grades as A minus, B plus, B minus, so on and so forth. In other universities, you may have like A, B, C, D, right? So attributes, they also have some constraints, and all those things we can add. All right. Now multiplicity constraints, right? So what is it? Multiplicity is a constraint that is defined on relationships. So this is something you need to understand. Okay, so when we looked at different kind of multiplicity, like one to one, one to many, many to many, then what are these? These are kind of constraints or the rules that governs how two entities would be related to each other. All right, and that relates to the entity instances. So something that I was trying to explain in my own words is more systematically given here. Multiplicity constraints on relationships. It identifies the number of occurrence of one entity that may relate to a single occurrence of an associated entity. Alright, so it kind of explains the same thing that I was trying to explain using a much better wordings. Alright, so example you have right here that one nation lists many stocks. So this is one to many. This is one to many. One nation, many stocks. This is one to many. Multiplicity. Okay, let's move on. Now in ER notations also we have different standards or different ways to show the multiplicity. You have Chen's approach, we have IDEF1X, Bachman's, Crowsfoot, ISO, and UML. Now today the RDM that we'll be creating would look like what you are looking at right here, and this is something which we will be using which we will create using MS Access, right? So MS Access supports this kind of what I should say, multiplicity. So we have awards, and here is the organization. So if you could recollect from the award data, and let's assume that we are splitting the awards data into two tables. In one table we have the organization name, and the other table we have different awards that different organizations have got. So you should see that one organization must have received multiple awards, right? So here the multiplicity that we have is 1, which is quite clear with the number 1, and this infinity means many. So MS Access has this notation of using infinity to show the many parts. One organization might have received multiple awards, so that's the reason we have one-to-many relationship between the organization name and the awards. These are two different tables right now. Okay, so the interesting thing is that one-to-many relationship is very common in our day-to-day life. So here, if you have some hierarchical system somewhere, and you have to map that to a database design, then you can achieve that by having one-to-many relationships. So just think about an organization or a firm. Then that firm will have multiple divisions, and each division will have multiple departments, and each department may have multiple sections. So we have three levels of 1 to m relationships, and all these are kind of representing hierarchical relationships. Okay, so now is the time to make our discussion more concrete, and we will use two tables to understand the relationship that we have, which is of 1 to many, and here we'll be using two table nations and shares. So what do we have here? We will split this information about nations in one table and shares in the different table in the second table. So we have two tables, nations table and shares table. So what so the nations information. Okay, so what we are doing here, we are providing the nation information in a separate entity, which is nations, and shares information in a different table we call shares. But in the shares table, we will also keep the information which will link a share to the corresponding nation. So that's what we mean. We include the nation's information in the shares entity. So although we are splitting the information about nation and shares into two tables, but we are keeping this information which will help us in connecting a share to the corresponding nation. And in the nation, we have the information only about the nation. Okay, so now you might be wondering, like, why is this person making the life so complicated? Why not keep everything in one table? What we need, you know, uh, if you remember the previous data about shares, then probably we did not have any information about the country in which these shares were listed. We just had the share specific information, their code, their name, quantity, PE. Okay, yeah, and few more, I don't remember exactly, but we did not have the country information or the nation information, like where exactly those are listed. But now we have additional information. We have the information about the country in which these shares are listed. So you might wonder, why not add those columns as well in one table and keep our life simple. But the answer to that is no, we will not do that, because that is considered a bad design. As per database design, that is considered a bad design, because what will happen, we will have some problems which are called as anomalies, and this is a very important important concept, anomalies. All right, understanding of anomalies is very important in DBMS. So including nation's information in shares entity will cause anomalies. So we should split the table into, we should create two tables, one for nation, the other one for shares. Alright, so let's try to understand anomalies, because this is a very important concept. So as you wanted, probably what we are doing, we are putting all the information in one table, and we'll see like what will go wrong if you put everything in one table. So we already had ID in the previous shares database or file, you had code, you had shares name, price, quantity, dividend, and P. So this much we already had. Now what we are adding the nation name and the exchange rate. Okay, so the first few shares, if you look at, these are all listed in UK and the exchange rate is 1. Then we have couple of shares after that which are listed in USA and we have corresponding exchange rate. And similarly, the last two are the shares listed in Australia and they have the exchange rate that corresponds to Australia. Now, something which is very intuitive right here you can figure out, and that is about the redundancy, right? So redundancy is a technical term that we use in databases. Redundancy, which relates with duplication in the record. So pay attention to the fact that UK1, how many times we are repeating UK1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times the same information we are repeating. Similarly, USA and its specific exchange rate, we are repeating it multiple times. Similarly for Australia. So one thing you can straight away get is that we are wasting a lot of storage. Right? This is a very small toy data, so you might say, okay, it's fine. But in real life, when you are dealing with really big data, then this will be a huge wastage of time. Sorry, wastage of space and hence time as well when you're processing. Okay, so we want to avoid that. So that's very intuitive way of looking at it. But there are some other problems also which are reflected by anomalies, and anomalies arise because of the redundancy. The redundancy in the database results in anomalies. Alright, so let's look at anomalies, like what are the different anomalies that we might have. So these are very important. Update anomalies, and there are three types of update anomalies: insertion anomaly, deletion anomaly, and modification anomaly. So what do we mean by insertion anomaly? So insertion anomaly says that when you have to insert the detail of a new nation, right, that does not have any stock. Is that possible? Right, so here if you look at this table, then seems like the main information is about shares, and then we have the remaining information about nation name and exchange rate. Think about a scenario where you want to insert some country's information, but that country does not have any share listed in there. So seems like it is not possible to have it here because probably ID is your primary key or code is your primary key, and if you do not have any share in that country, then the primary key cannot be null. So you'll have these things as null, right, which is a problem. You cannot have a primary key as null. Okay, so when you want to insert a record in this table for a country that does not have any share, then it's impossible to insert that. Okay, so that is a problem in insertion. You cannot insert a country that does not have any share there. So that is called insertion anomaly. I hope you got the message why it's not possible, because say you have a country called XYZ. Okay, may have some exchange rate 0.33, but you don't have any share there. So when you don't have a share there, then possibly the code, and code is our primary key, it has a value null, right? So that is not allowed. Primary key cannot be null, so you cannot insert that, right? You should have some code value or some value from the primary key, then only you can insert. And how about deletion? So deletion is related with insertion anomaly. So what does it say? Suppose that there was one country, okay, there was one country with one share listed in the database, and if that share is somehow removed, right? So what happened? Let me take you back here. Assume that Australia has these two shares, okay, and for some reason we remove these two shares. Now the point is that after removing these two shares from our table, can we still keep Australia information? Answer is no, you cannot, because Australia does not have any share. So since the shares have been dropped, we cannot keep Australia in our database. So Australia should also be thrown out, right? So that is called deletion anomaly. So when we delete the last stock, we lose the information about the nation, which is bad. Okay, when we delete the the last stock, we also lose the information about the country. So this is called deletion anomaly. And what is modification anomaly? Modification anomaly says that if the change you are making at a nation, then that change must be done for all the records containing that nation. So let me explain that to you right here. Assume that the exchange rate of UK changed to 0.9. So that exchange rate, you have to do, that update or that modification of the exchange rate, you will have to do for all the records. Okay, you'll have to update that here, here, all these 10 instances, which is inefficient, and it may result in some inconsistency. Okay, so that's another problem which we call as the modification anomaly. So considering these three anomalies, which are insertion, deletion, and modification, which are result of the redundancy, we will not consider putting the information about the nations along with the shares in the same table. I will discuss these things again when we will be looking at normalization. Okay, now the point is fine, we have done the design. How should we ultimately implement this design? How should you map the RDM or the ER diagram to the relational database? So this is straightforward. What we do for entities, it is straightforward. Each entity is mapped to a table. Okay, so we will have a table. Let me take you back to this, sorry about that, I'm going too far back. Yes, so what we will do, we will create one table for nations and we'll create one table for shares, and all these attributes that you had for nation entity will be there in the nations table, and similarly all the attributes that you had for shares, they will be kept in the shares table. So that is very simple, mapping the entities to the table. Alright, each entity becomes a table. An entity name becomes the name of the table. That's simple too. And each attribute becomes a column. Alright, yeah, it's very simple. And for this one-to-many relationship, even the relationship is very simple to implement. So please pay attention to this. Now, add a column to the table at the many end of the one-to-many relationship. Okay, and put the identifier of uh, the one ant in the put the identifier of the one ant in the added column. So yeah, this is kind of getting a little technical. So what do we mean by that? So let me let me use my way, which is ER diagram. So here we have nations, and on the right hand side we have shares. Alright, and there is a relationship between these two, and I can call this relationship as listed in. Shares are listed in countries. So this is one to many. That is another notation. One nation instance is associated with multiple shares instance. Now we are saying that we'll have a table for the table that you have for nations will have ID, name, exchange rate. Okay, so that is what you'll have for nations table. And for shares, you'll have all the attributes that you had for shares. You had the attribute like, what was that? ID, you have code, you'll have name, and that's not important, you can figure out. Now the point is that we want to know how will we implement this relationship, which is one to many, the relationships between nations and shares. So the answer to that is that, that's the point I'm trying to explain. So I'm trying to explain these 2 points here, the last 2 points. Add a column to the table at the many end. What is many end? This is shares table. Okay, shares table. So many end is shares. So we are adding one column right here, and in that column, this is many end, this is one end. So add a column to the table at the many end, add a column to the table which is shares, and put the identifier of the one end to that end. What is the identifier here? ID. Okay, so this is the identifier or the primary key of one end. One end means this guy. One to many, that's one end, and many is this side. Okay, one and many end. Alright, so this ID that you have, this information should be kept here. Alright, and we will give it a different name. We will call it nation ID. Okay, so that's how it's so simple to implement one to many relationship. Alright, so what are we doing here? We are implementing one to many relationship. Okay, relationship. All right, so that's about it. That's about the last 2 points. Okay, so let me show that thing to you using a very simple neat diagram. Here you have uh, the table for nations entity, your ID, which is our identifier or the primary key. You have the code, which is another attribute, nation's name, and then the exchange rate. Okay, now we have an interesting thing of foreign keys, which I'll explain to you later. Okay, maybe that's the time to explain to you foreign keys. Alright, so what is a foreign key? Let me explain from here. When you added an identifier, right? So what you're doing here, you're putting the identifier of the one end, which is ID, at the in the column at the many end. So this nation ID that you have, which you created by using a column which had the identifier of the one end, then this attribute or this column is called a foreign key. This is a foreign key. Why is this a foreign key? Because what do we have here? This new column that I created, I'm using this column to keep the primary key or the identifier of the other table. What's the other table? The other table is the table for the entity that corresponds to one end. Alright, so this new column that I'm creating in the shares table will have the values of the identifier or the values of the primary key of the other table. So I will call this attribute as the foreign key. Right, so you should get the concept right here, and then I will explain that to you with the help of this definition. Now what is a foreign key, right? So let's try to understand foreign key. Now the 1 to m relationship between two entities is implemented in database with the help of a foreign key. That's what we did, right? We implemented the one to many relationship between the nations and the shares by adding one more column to the shares table, and that column we called as foreign key, and in that foreign key we are keeping the value of the identifier of the nations table or the primary key of the nations table. And why did we do this exercise? This exercise was done to implement one-to-many relationships. All right, yeah. Now, what is a foreign key? Foreign key is a column whose values are the primary key of another table. Okay, so if I'm asking what is a foreign key, this is a perfect example. Or sorry, the perfect definition, I should say. And if you want, you can use an example, right? So, if you have time, then please try to explain your definition to the best you can. I don't expect you, and I will not encourage you to memorize the definition. Please do not memorize. Just try to understand the logic behind it. Try to get the concept. And if you feel that what you have written is not good, then use an example. Sometimes the example is a lot better than the definition. Okay, so use the definition as well as an example to convey the definition. Okay, and probably you will have time in midterm, so, and final as well. Okay, so let's look at this case and try to understand like what is a foreign key. So here we have both the tables. You have nations table here and you have the shares table here. Now we have added one column here. Let me call that foreign key. FK means foreign key. And alright, so what is happening here? These are all the original attributes of the shares table, and what we are doing here, we created another column which is we are calling as nation ID, and in the nation ID is our foreign key. And look at the values that we have for each share. So why do we have one for the first first 10? First 10 shares have the nation ID value as 1. Why? Because you can match this one with the ID field of the nation table, and by doing that manual matching you will be convinced that we have this value so that we can map this information, right? So if you match this one with 1, then that means this share that you have, these 10 shares that you have, are listed in UK and they all have the exchange rate of 1. So look at the saving that we are doing, right? So we are saving a lot of space, right? And we are in a way solving the problem which might arise because of the anomalies, right? So if you have to delete the shares right here, delete the shares. You don't need to delete anything from the nations table. Nations will still exist, irrespective of the fact that whether they have a shares there or not. This is independent, right? And similarly, that's the case with the shares. Okay, did I explain? Yeah, nation ID is the new shares table. Nation ID in the new shares table is a foreign key that refers to the nations table. This is called referencing. Okay, that's the technical term. When you have one here and these when you have these values which we are kind of getting from the identifier, the primary key of the nations table, then that is also called as this field referring to the primary key. Okay, this is also called referencing, right? So if you want, I should write that foreign key field references sorry about my handwriting here. Foreign key field references the primary key field of the original table. This is getting a little technical actually. What I should do rather, I should use I don't want to make it too technical. Of shares. Let me write this in connection with the example. So foreign key field of shares references the primary key field of the nations table. Now it should make sense. Actually, there are more terms which I don't want to introduce right now, because that might make it even more complicated. Alright, so I hope that you are getting this concept of foreign key. Now this is a little more technical to follow, but I'll try my best. What is referential integrity constraint? So these terms are a little heavy. The concept is very simple. So there's something called as foreign key constraint, and a related constraint is called referential integrity constraint. So what is the referential integrity constraint? Believe me, it is very simple, but this term is a little heavy. So what do we mean by that? So let's read it, and then I will explain to you what this term means. Now, for every value of the foreign key, there is a primary key with that value. Okay, so let me take you back here. Look at all the values that you have here. So ones, why do you have ones? Because these ones, because there is a value of the primary key with a value 1. So why did we put 1 here? Because this one is a value that I have in the nations table, so it is perfectly fine. I can keep 1 here because there is an entry in the nations table where the primary key is 1. Similarly, I can keep 2 here because 2 exists in the nation table for United States. Similarly, 3 is fine because 3 is here for Australia. 4 is fine because 4 is here for India. Now if I want to do something like this, let me in place of 4 put a 5. Now that is not allowed, right? I cannot put 5 here, because if you put 5 here, then this violates, this violates, sorry about that, this violates. So let me erase. I'm not very happy with my okay, this violates. Oops. Okay, so I hope you got it right. My attempt to write that is failing. So this is, let me, instead of writing violates, let me put a cross. Okay, this is not allowed because of referential integrity constraint. Referential integrity constraints does not allow you to put 5 here. Why? Because whatever value you are putting in the foreign key, that value should exist in the primary key of the referred table. This is called referred table, and this is called referencing table. I did not want to introduce this term, but anyway, I think that will have referencing table. This is referencing table, which is shares, and the referred table is, I think we should have 2R. The referred table is our nations table. So whatever values that you have in the foreign key, that value should exist in the corresponding table in the nations. Okay, so here we were fine. This table was following the foreign and the referential integrity constraint because all the values existed in our nations table. But if you get a value like 5 which does not exist in the nation table, then that means you are not following referential integrity constraint. So that's what we have in the definition. So let me take you back. Referential integrity constraint. It says that for every value of a foreign key, there is a primary key with that value. Okay, for every value of the nation ID in the shares, there is a value of ID in the nations. Okay, and what I attempted to do, I attempted to put a 5 here, and 5 does not exist in the nations table, so we have a problem here. Okay, a primary key must exist before a foreign key can be defined, so that is a requirement. So whenever you feel that you will be using a foreign key, so better you first create the referred table, right? So for this case, first you should create a table, nations table, and then only you should be creating a shares table, because in the shares table you will use a foreign key, and this foreign key will have to refer to the primary key, which is ID of the nations table. Alright, so now we will look into the tool that we should use to show this relationship, which is one-to-many relationship between the nation and the shares table. Alright, so these are some steps which you should follow, but what I will do, I should do that as a demo for you, and you should try doing that at your end also, and it is little tricky, so please pay attention to what I am doing. Okay, so let's open Access and we'll create a new database, one to many. I'll call it one to many. We will create this, and then let's create a table, and for the table we will use external data. It's coming from a file, that's an Excel file. We need to browse. I will go to my folder, that's where I have the data. I'll use nations file, and this file is already there on the blackboard, so please download these two. Okay, so it's a very simple one. It has first row as the heading. It's asking, not asking yet. Yeah, the Access is asking that should add a primary key. I don't mind, I'll say yes, please go ahead. Import to table, I should give it a name. I will call it nations. Okay, and should be capital nations. Alright, let's finish. Close. So yes, I do have the nations table created, no problem. And now we should create one more table for shares. I should say external data. Let's follow the same approach, and from files, Excel, browse, shares 2. Alright, so this shares that you have is the previous one where we have a very simple shares, but the shares 2 is a different file. So I do have shares 2 also. So for this exercise, please use shares 2, not the shares. Let's say okay, then yes, yes. Asking to add a primary key, I will say yes, please go ahead, I don't mind. And I will call it shares 2. Let's call it shares 2. Okay, you can call it shares as well. Finish. Let's look at shares. Nice, we have shares. Okay, and look at the foreign key. We already have a foreign key. Table 3 I don't need, I should close that. Table 2 I don't need, I should close that. Same I'll do with table 1. I'm left with these two tables, nations and the shares. So this is the primary key of nation, and it has values 1, 2, 3, 4, and here you have nation ID, which is the foreign key and has the corresponding values which are already present in the nations table. So we have, in a way, referential integrity constraint ensured. Now we have to learn something new in this lecture, and this new thing is using the tool to show the relationship between these two. Now for that thing to happen, let me tell you this thing, and please try to do it before you even attempt to create the relationship diagram. Now this foreign key attribute that you have should have the same data type as your ID field in the nation. Okay, because if you don't do it, it will create it will make your life really difficult. So make sure that the data type for nation ID is same as the data type for ID. So how do you check the data type for ID? Use the nations table and then go to the design And here you can see that the ID for nation is your primary key right here, and its type is auto number, and which is long integer. Alright, but the problem right here is that if you go to shares and look at the design view, you will see that the ID of the shares is fine. It is long integer, just like the ID of nations. But we are interested in nation ID, and nation ID by default is different. It is double, right? So what we have to do, we want to make it long integer. Why? Because this field that you have, which is the foreign key field of the shares, should be of the same type. It will ask you for this thing. We'll say yes. That's okay, right? Just we want it to have the same kind of data that we have in the ID field. Alright, so please do this exercise. Make this data type of nation ID same as the data type of the ID field of nations. And after that, we can do the design part. So from here, come to the database tools. In the database tools, you have this symbol called relationships. Click that, and when you click it, it will show you the different tables that we have. We will pick these two tables. We need both, and then now we should close. Alright, so these are the two tables that we have, and we will show the relationship. We'll have to learn how to model relationships or create the RDM in MS Access. So once you have these two tables, just double click left. So this will pop up. Here you should say create new, and when you say create new, then it will attempt to create a relationship between the two tables. Now you need to pick a left table. I will say nations as my left table. The right table I'll pick as shares. Now I need to come up with the column names also, so that these column names are kind of connected with the help of the foreign key relationship. I will say that let's link the ID field of nations with, I think there's something has gone wrong. I had shares here. I will say nations ID. Alright, so from nations I'm picking ID, and from shares I'll pick nation ID. Why? Because this foreign key that you have right here is linked with the ID field of the nations. So that's the reason. That's what we are doing in this box. Then you have this box. Please click that, because we want to enforce referential integrity. We just learned about referential integrity in the lecture. Say create. Okay, so this is something you might see. So I'll tell you why is that happening. So let's close this one, and we should close these tables. Okay, close these tables, and then go back and create the relationships. Okay, now we will do this create new. Left table is nations, or right table is shares. The left I'll pick the ID field, on the right I'll pick the nation ID. I should say OK, enforce referential integrity, and create. Alright, so we got it, right? We were successful in creating the RDM in MS Access, which is showing the relationship that we have between the nations table and the shares table. And here this one that you have, it is showing this one, and infinity symbol is showing the multiplicity, which we have as one to many. One nation has multiple shares listed in there. Okay, so that's the exercise which you have to do. So please follow the steps that I showed you. And anyway, I have these snapshots in my lecture slides also. Okay, so you will start from here to create a relationship in Access. First click on the relationship in database tools tab. That's what we did. And then you click and after clicking you'll get create new to bring up the create dialog box, and then you need to follow the same way. and for every value in the foreign key there is a primary key with that value, and which will be enforced through the referential integrity constraint. Alright, so you should enforce referential integrity constraint, and that's how ultimately you will see the relationship. Now, one thing you might have noticed on, I think as far as I remember, in the demo that I did, nations was on the left hand side. It does not matter whether you have nation on left or on the right. Look at the connection and the number. With the nation, on the nation side I have 1, and infinity I have on the share side. So pay attention to these numbers, not on the relative orientation of nations and shares. Either one of those could be on the left. Alright, so what's the exercise for you? Like, are we on track? Well, I have given you these two tables on the blackboard. Please download those and try to create these two tables, and using these two tables I'll just make this diagram. Okay, so did we achieve the objectives? So in this lecture our objective was to understand one-to-many relationships, and we also understood about relationship, right? So we first tried to understand when will we have relationship, what kind of relationships we can have. So very briefly I explained to you about different kinds of relationship on the basis of the multiplicity. It could be one to one or one to many, many to many. But the example that we took in this lecture was about one to many relationship. Alright, and we even modeled that using the MS Access tool. Okay, so we are done. Alright, I'm done with this video lecture. I'll see you in the next video lecture. Bye bye. Take care.